Hey, good morning, everybody. Thanks for calling in. What you've called into, either accidentally or on purpose, is a webinar hosted by L3 and Loadbanks Direct. And today the topic will be pros and cons of stationary versus radiator mounted load banks. I'm sure things are going to be talked about like cost, size, complication, engineering time, longevity, that kind of thing. We're lucky enough to have Eric Mercer with us from Loadbanks Direct. And just a couple housekeeping items. This is a webcast, so your phones are on mute if you're an attendee. But we would love for you to ask questions. There's a question box right there to the right of your screen. So please ask questions, and if anybody wants to test the question box, go right ahead. And also there are a few handouts that can be found to the right side of your screen as well. There's a PDF of the presentation and some brochures on radiator mounted load banks and stationary load banks. So without further ado, I'm going to turn it over to Eric Mercer.
Morning, afternoon. Thanks for joining me, guys. My name is Eric Mercer. I'm an application sales engineer with Loadbanks Direct. Just going to be doing a fairly brief summary of stationary versus radiator mounted load banks. Today is Michael was kind enough to inform you guys about. So without further ado, I guess I'll hop in here and get started. First, but I do have a question I'd like to pose to you guys. If you could take a second to answer it, Mike will get it to pop up on your screen, just because I'm trying to get a feel of what kind of load banks you guys are familiar with, what you see specified most often. So if you guys could take a second to answer that, that would be greatly appreciated. Just give me a little bit of feedback on my audience here.
Hey, Eric, this is Pico. I'm here with you too. So if I'm going to let you kind of take the lead here, but if you need something, let me know.
Yep, absolutely. We actually just got started. Everyone, this is Martin Pico. He's our Senior Vice President of Engineering and Sales. He's the brains behind the load bank. So thanks for joining us, Martin.
Great. So it looks like we have a nice response. 74% of the audience voted stationary, and 26% said radiator mounted.
Okay, so you guys are definitely, sounds like you guys are seeing more stationary units than you are radiator mounted units. All right, that's good. That's good information to have. There's pros and cons to both. So I'll just get started. The first section we're gonna go over is our stationary load banks. So stationary load banks are freestanding, fully contained load banks. They're self-cooling. So they've got a blower, impeller. It's forced air cooled to cool the resistors. They have the ability of loading generators to 100% of their capacity. So I mean, realistically, they could be sized bigger than the generator. There's no reason for that. But since they're self-cooling, there's no limitations to how large you can size them and what size of generator you can pair them with. They come standard with remote controls, because typically they're installed outdoors. So you can mount your remote controls in like your generator control room, or really wherever you please, where they're convenient to operate from. And they're all outdoor rated. So the outdoor unit is NEMA 3R to keep all the control components nice and dry and clean while it's installed outside. So those are some of the big points on the stationary load bank front. The biggest one being, when you're comparing it, we're going to get to the radiator mounts, but the biggest comparison is you're able to load to 100% capacity of your generator because they're self-cooled. Picture here on this first slide Just a quick little reference from moving from left to right on here. That's our smallest cabinet we personally offer. We can get up to 200 kW in this small enclosure here. This one next door to it in the middle here, we can get up to 800 kW in that guy. So from 0 to 200 kW here, 200 to 800, and something similar to this, a single stack of resistors with one blower. And then the third one, that's up to 1250 kW in a single stack, one blower, one single stack of resistors. And as you can see, they grow pretty fast as they go up there. We also make them all the way up to 3 megawatts, and then once you get past that 1250 kW threshold, they turn into multiple stacks of resistors, as you can see in this picture. So this unit right here would be like somewhere between 1500 and 3 megawatts in this double bay enclosure here. This is the side profile of that 1250 kW cabinet. Just has the static exhaust hood installed. And then this is just an installed picture of one of the smaller enclosures, just for a little bit of reference information. But all of these can be installed and are very likely paired at 100%. 50, definitely, majority of the time you see them between 50 and 100% of the generator capacity, just because that is the major point of utilizing a stationary load bank is being able to load to 100%. Moving on to our radiator mounted overview. So radiator mounted units, you guys, it seems like you guys, what we say, 26% of you guys are seeing these less often than the stationary load banks. There is a time and a place for both styles of units. So a radiator mounted unit are typically sized at 30 to 50% of the generator capacity, and are designed kind of as a supplemental load. In comparison to the stationary that you can go to 100%. They're not self-cooling. They mount on the face of the radiator and utilize the airflow that's being used to cool the generator and blowing through the radiator to cool the resistors as well. And they come standard with local controls, typically because they're inside of the enclosure and usually easily accessible depending on the application. But they can be offered with remote controls as well. So you could mount this thing on the face of your radiator. You can't really get to it. Still be able to mount remote controls inside of the enclosure in the generator control room to operate it. Radiator mounted load banks, they're indoor rated when compared to a stationary load bank, and that's because stationary load banks are typically installed on a concrete pad outdoors, as I mentioned. And these are mounted on the face of the radiator. So they're going to be either inside of a custom enclosure typically, or on like an open generator set. So they don't really require the outdoor rating.
Hey Eric, where's the cooling fan on these resistors?
Oh, they're not self-cooled. So they are being cooled by the generator's fan that's blowing through the radiator. So it goes from the fan through the radiator and then to our load bank to cool all the resistors. And this picture here, this is obviously not an installed unit. This is a stock picture we have of one of our units from the floor. You can see all of our resistor elements stretched across here in this gap. So typically your radiator, the face of your radiator is going to go from this corner to this corner and down. These are all sized custom to the size of the radiator. So these are a little bit more of a custom unit than a stationary. As before I mentioned, we had all those different size enclosures depending on capacity. With a radiator mounted unit, we could have a unit where this window, is 8 foot by 8 foot wide and only have 200 kW in it. But we could also have one that is 8 foot by 8 foot wide, and has, 400 or 500 kW in it, or even smaller. It just ranges depending on the radiator, the amount of airflow required, and then the capacity of the unit. So they're definitely a little bit, each one is a custom drawing, or it's a custom unit, depending on the face of the radiator, and options selected, such as remote controls versus local, and other.
Yeah, what Eric's trying to say about the application, or what he is saying very, very eloquently about the application of these, is that they, I personally call them kind of it's an econoline. It's an econoline solution to being able to offer a load bank to keep a minimum load on the generator. We all know that generators are so tremendously oversized. You know, people use 1,000 kW generator in an installation, and they may not even have 200 kW of connected load. So the ideal solution is to have a stationary outdoor load bank like the one he had on his previous slide, which is it's got its own cooling fan. It's bigger. It's obviously more expensive. You know, that a 1 megawatt installation like that might be a $18,000 load bank. So you go back to the radiator mounted load bank. If the 1,000 kW generator is in a generator set enclosure, there's a custom housing for it. They'll leave room for the load bank. You could see the depth of the load bank is typically about 14 inches. It could go up to 20 inches. You might ask yourself, why is LBD recommending that it be 30 to 50% of the generator capacity? It's because you kind of can't break any laws of physics here. The radiator cooling fans on engines are designed to take the heat away from that's what they are there for, to take the heat off the engine. So we capture that airflow. When we say what the core dimensions are of the radiator, we typically need that information at time of order, but that we make our opening for the resistor frame, like Eric was saying, the same size as that. We mount the resistors in there. We capture that airflow coming off there. But you can, if you need more watts, you need more heat, you need more resistors. So if you tried to put 1,000 kW, a megawatt worth of resistors on the tail end of a radiator that's cooling 1,000 horsepower or 1,000 kW engine, you're probably going to overheat something in the system. And also, you're adding so many resistors at that point that you're probably exceeding the static pressure rating of the radiator fan. So we found in our experience 30 to 50% is a really good number to work with. We can go a little bit higher. We just kind of need to know them on a case-by-case basis. And when Eric said that everyone's done custom, that's true. But we've streamlined the process. We do it quickly, and we're just that versatile. And that's just that extra level of versatility that we're going to offer. All we need is those core dimensions. Doesn't matter if it's a Cummins, Cat, Kohler, whoever's radiator that they're using, a high ambient radiator, whatever it's sized for. Give us those core dimensions. We'll figure it out, and we'll make it fit. And the packager installs it. So when I say it's an econoline solution, it really is, that 1,000 kW load bank that's outdoor stationary, that has its own pad. You got to run conduit to it. You got a cable up to it. You have to have a separate breaker for it. It's not just an $18,000 load bank. It's got installed costs associated with it as well. With the radiator mounted load bank, the packager can put it in the housing. They can have a separate breaker that feeds the load bank. And, the hardware cost alone for a 500 kW duct mounted load bank might be half the cost. It'll be less than half the cost of that. It'll be like $8,000 to $9,000. So it's a very cost-effective solution. It's not always the best solution, because if you need that higher capacity, then you need to go into a stationary application. But in a duct-mounted application at 30, 40, 50%, where you want to supplement or keep a minimum load or meet the NFPA 110 requirements of testing that generator under load or getting the engine up to operating temperature to minimize the adverse effects of wet stacking and unburned fuel deposits from building up within the engine, this is a great solution.
Yeah,
Sorry,
this
Eric,
is definitely. No, you're fine. This is the radiator mounted load banks are definitely definitely like as you guys said, 3/4 of you guys are seeing the stationary more. But the radiator mounted load banks really are kind of seem to be the bread and butter when a load bank is going in a custom enclosure typically. That's another can be a limiting factor on where these can be utilized. If they're going in a factory enclosure, typically they won't have room for them. So that can be another factor that comes into the decision making process of that your installed cost versus how much load you need to apply on your generator with the load bank, however size it is, etc. And then touching back on these each being custom window sizes to pair with your face of your radiator. That's super important because we need to capture all that airflow. We don't want hot spots on our resistors where they're not catching airflow, or potentially maybe ours was too small for a radiator. Then we don't want to be restricting additional airflow through that radiator either, and cause potential issues with the generator cooling properly. So that custom size is very important. And then I have a great example on this next slide of showing you what not to do when these are sized wrong. So as I mentioned, these are indoor rated load banks. As you can see, this load bank, for some reason, somebody decided to mount it on the outside of an enclosure, no protection, nothing keeping somebody from being able to walk up and stick their hands in this thing and get electrocuted. You can see the window size does not even match the outflow size of this thing. So there's like 100 things wrong in this picture alone that conflicts with everything we just described to you as being important for these units as far as the concept of how they work. So that's just, I thought that was a good example to throw in here of what not to do and what we're
that is a really good picture. And, hanging it on the outside of the enclosure is a solution, but it's not always the best solution. You look at this and there are a lot of things wrong with it. And then just from an aesthetics point, it just doesn't look clean. The right thing to do is try and put it inside the enclosure. Now, a lot of the smaller generator sets, let's say, I'm just picking a number, let's say 250 kW and below, they're not put into a custom walk-in enclosure. It's like a factory enclosure where there's not room to have that side contactor box. There's not room to wedge a load bank inside there. So I think Eric's going to talk to you about some roof-mounted solutions that we have for that might be better than trying to couple it directly to the radiator, like somebody tried to do here in this installation.
Yeah, exactly. And like as I mentioned, sometimes the type of enclosure the generator's being packaged in is a deciding factor on radiator mounted versus freestanding. Well, it's also a deciding factor when you're talking about radiator mounted, a standard radiator mounted, like shown here, and going to which is indoor rated, and deciding for a rooftop style radiator mounted unit, as you can see on this slide. It's basically the same exact concept, except for they go on the top of the generator enclosure. And these can be utilized when you're going in a factory enclosure and you don't have enough room to squeeze a radiator mounted unit inside of the enclosure. You can mount one of these on top, and it's a very cost effective option versus it's way cheaper to mount one of these on top of a factory enclosure than it would be to buy a custom enclosure and save a few bucks to go to a regular radiator mounted unit, which comes back into that same conversation like Martin was talking about with the installation costs associated with a freestanding unit. But very same exact concept, except for these are outdoor rated, same size or general size, 30 to 50% of your generator capacity, because it is the same concept. It's still utilizing that radiator, that cooling airflow from the radiator. It's just being typically vertically exhausted out the top of the enclosure. On these, remote controls are standard versus our regular radiator mounted unit where they're local, and that's because they're up on top of the generator and you can't reach up there. and operate them. So it's can be a nice, depending on how it's installed, can be a very nice, clean installation. Have your controls, inside of your enclosure in your generator control room, wherever you want to mount them, and get the same thing done, but also while working with a factory enclosure. So it's kind of a budget, definitely budget driven. Very, very frequently, I see it's budget driven. Is how we end up with these.
They're both
these are really a cool piece of equipment.
Question came in. Really what are the most common problems observed for radiator mounted load banks?
I would say, I don't know what, Martin, what do you think? Heat's always a problem in all load banks, though.
Heat is always a problem. And, when you get people that say, hey, I have 1,000 kW, I'm just using round numbers, 1,000 kW genset. Can we put a 750 kW load bank on there? And we go, well, we don't really recommend it. Can we do 500 or 600 kW? And they say, no, the engineer and the spec says it's got to be 750 kW. We take a closer look at it and figure out, yeah, we can do it. And we go ahead and do it. And the customer and client gets it, and we got a temperature problem. It's just, I would say that's the most recurring theme that we have. And not getting all the information from the customer up front, like on these rooftop applications. Sometimes there's mufflers that could be in the way on a standard factory housing. So what we'll do is just request, hey, can we get a drawing from the Generac, the Kohler, or Caterpillar, whoever's enclosure it is? Can you show us the available opening up top? And usually, if we get that information correct up front, there are no issues. Where we do have issues is somebody says, well, just make it 40 by 28, or they just throw a number out and nobody really looked at it and confirmed it. And then we go, oh, wow, well, we got a space here where the resistors aren't getting cooled. So it's really about just getting the available opening where airflow is and sizing it properly in that 30 to 50% range, and also getting the voltage right. We have had instances where you put a maybe not a rooftop, but like a 500 kW genset with a 250 kW load bank, and they put it into the custom Pritchard Brown enclosure, walk-in enclosure. It's all installed, and it's 480 volt, and they go, no, it's not. It's 208 volt. Well, just reconfigure the load bank for 208. No, you take the whole thing out, and you have to put in a new. It's a major amount of rework. So it's really about just getting, and we're pretty good. The LBD is very good about that. If we feel that we don't have the right information to start, we'll come back to you and make sure that we ask for it. Eric, go back to the previous slide. One more.
That's the one you're looking for?
Now, that one right there. So like the open frame of resistors that you see there, and the one on the right, that's a perfect example of that might be in a housing, but sometimes a generator might be supplied to a hospital and it's going in the basement somewhere and it's just on a skid, and they have, or in a penthouse, and they have, air intake louvers that open up to let fresh air in when the generator runs. And then there's ductwork that goes from the radiator exhaust fan out through a plenum to the outside of a building, and in between there is where they'll pipe in sheet metal around the opening so that we capture all that airflow. So it could be an indoor application where it's just put into an air plenum where the radiator exhaust air is exiting the building, and then we wedge the load bank in between that. So getting those dimensions correct prevents any type of heat issues. Sizing it, at trying to keep within that 50% range keeps us out of trouble.
Yeah, that's a sweet spot, definitely on the non-self-cooling. So basically, yeah, on the radiator and roof mounted, that's the sweet spot for capacity. as far as making sure that it cools properly and you don't have any issues down the road with over temperature, cooling your generator properly, etc.
The nice thing when a packager does all the installation, whether it's a rooftop onto a factory housing or a custom packager, a Pritchard Brown enclosure, a Robinson enclosure, where you got a big gen set. I mean, we could do a duct mounted load bank as big as 1,000 kW. It's UL listed, and it's a big 2,000 kW generator or 2250 kW generator. You walk inside there, and the load bank's inside there, and it's installed, and it's wired back to the breaker. So when the client gets it, they have the load bank. It's integrated into the genset package. It's put on one pad, and it's clean. It's a nice clean installation. It's not always the best solution, but it's just a different solution. Now, some data centers or municipalities might have or consulting engineers might have a requirement to say, look, that 2 meg gen set, we need to test it, 30 minutes or 1 hour every month at 100% load. So then, the stationary application is much better suited for that application. Well, it is the only solution for that application. And the disadvantage there is that it's another piece of gear, and it typically just gets an extension of the pad for where the generator is, and the load bank sits local next to it, and then it's wired into a breaker indoors.
Great. One more question came in. If you install a radiator mounted load bank on a generator exhaust, do you have to derate the generator since you are reducing the airflow?
Okay, so the answer to that would be no, as long as we haven't exceeded the static pressure rating of the radiator fan. And let me elaborate further. If we're in that 30 to 50% range, we are very cognizant of putting only a certain number of resistors there to not. Our static pressure on our resistors, the drop is about 1/8 of an inch of water column. Okay, the radiator fan can typically handle up to a 1/2 inch or greater. So we're below that threshold. So no, you do not need to derate the kW capacity of the generator.
Yeah, that's a good question.
That's a great question.
Yeah. So that comes back to the 30 to 50% being the sweet spot for this style of unit, and that's another driving factor. As soon as we start adding more and more resistors and more static pressure, then that's when we get into trouble. Absolutely. And back on these rooftop radiator mounted units I touched on, they were they were a big hit when it came to using them with a factory enclosure and not having to increase your installation costs and just be able to plop it on a factory enclosure instead of having to go to a custom enclosure. So these are just two pictures of some installations that we've seen in the field, or pictures we've gotten back from some of our customers where they were installed. And you can see both of these. Neither of these are walk-in enclosures. I don't know exactly what the percentage these are, but they're definitely in that 30 to 50% range. And this is just two examples so you can kind of visualize how they're installed. And this one on the right, you see they've got a little bit of sheet metal there. I don't know why. Usually it's not required. Usually it looks a little bit cleaner than that, but depending on some of those Cummins, the tops of them are curved a little bit. So sometimes there's a little bit of modification that needs to be done to do it. But usually it's very, very, very small in comparison with trying to implement a standard radiator mounted unit into a custom enclosure. That's an entire project. This is an afternoon project to install one of these. They're super, super easy in comparison. And then Michael, we had a question see if everyone is familiar or has heard of automatic load leveling or is familiar with the concept. Can you throw that question up for us, please?
Should see a poll question on your screen. And the question is, are you familiar with the concept of automatic load leveling? While we're waiting on that, there is another question you might want to answer. Are there any clearance requirements for the generator mounted load bank? I'm assuming they mean radiator mounted load bank.
Yeah, so clearance, obviously you're going to be getting hotter airflow out of your the end of your generator. If it's a radiator mounted unit, typically you're going to have hotter airflow, but not necessarily. There's not the clearance on the outflow of the generator doesn't increase because a load bank's installed there. It's going to be warmer air, but you're not going to walk in front of it and melt yourself down in this application. If we were talking stationary load banks, yes, they're vertically exhausted, so you don't have a chance to walk in front of them. But if they were laid down, I definitely wouldn't want to walk in front of one of those things because they'll probably melt your shoes off. But yeah, no, there's no additional clearance requirements surrounding your package generator set when you install a radiator mounted load bank.
All right, looks like we've got roughly 2/3 of the audience is unfamiliar with the concept of automatic load leveling, and 34% are familiar with it. So it's a good time for you to explain what is automatic load leveling.
That's cool. Hopefully my explanation will be beneficial. Get that a little bit established. So automatic load leveling. This is something we offer on all of our permanently installed equipment, so stationary load banks, radiator mounted load banks, rooftop style radiator mounted load banks. And what that is it's a series of current sensing relays that basically they monitor the building load, or they monitor the building load on the generator, and say that, that falls at, most of the time this generator's sitting there powering the building and it's only using 10% of the generator's capacity. So our load bank takes those measurements and then will apply load automatically without the operator, without anyone paying attention, as long as you got it in automatic mode, and we'll ramp the load of the load bank up and down to supplement that building load to try and keep that generator in that 30 to 50% sweet spot so that it's not wet stacking, or to minimize wet stacking. But it does that all automatically, just by monitoring how heavily loaded the generator is when it's running. And big pro of that is it's automatic, and nobody has to be monitoring this all the time, as long as it's set correctly when it's installed and set in the right mode. It monitors nonstop whenever whenever the generator's running, and does that automatically. It ramps up, it ramps down. Say it's usually only running at 10%. For whatever reason this day, it's running at 50%. The building's loading at 50%. The load bank sees that, says, oh, well, we don't need to do anything here, and it turns totally off. It still continues to monitor the building load for waiting for that next dip in demand so that it can apply load again, but it'll sit there and just be monitoring load, not adding any load as long as it's above that threshold. And typically when we design these, we design them to keep which it has to do with the capacity of the load bank as well, but it is also geared around, most people are saying the 30% is kind of the low end and 50% is kind of the high end for minimizing the wet stacking in these lightly loaded conditions. So we try and keep it in that window when we're supplementing load, depending on how heavily loaded the generator is. The load bank supplements load to try and keep it in that window of 30 to 50%. It varies a little bit, kind of depends on capacity and a few other things. But as a general rule of thumb, when that's in operation, it's keeping it loaded 30 to 50%, unless there's some kind of other driving factor. They want it more heavily loaded, less loaded. We can do that as well. But as a typical rule of thumb, we set them up to keep it loaded 30 to 50% when it's supplementing load. And then as I mentioned, move on to this next slide here. It's monitoring building load. So this is kind of a little bit of just a visual reference case that wasn't super clear on how it's doing it. So you've got your load bank here through generator, breaker, load bank. So that's one load on your generator, and then you got your building load. So your automatic load level it's just a control, or it's a current transformer that's just measuring it, basically measuring amps, how many amps the building is drawing, and only the building. It can't be measuring the load bank load, building load only. It takes a measurement there, sends the information back to our load bank. We say, hey, this thing's drawing plenty of amps to keep that generator loaded where it's not wet stacking, or hey, this thing's not even loading the generator at all. We need to turn on all our steps and get this thing loaded so it's not sitting there idling all day. So that's just a general kind of nice visual of how that circuit is arranged. Yeah, so it is a fairly simple concept, and it's definitely one of, if not the most common options that we sell on our load banks, on our permanently installed load banks, because it's a huge pro. It reduces maintenance requirements on your generator, not having it sitting there idling all the time, increases the lifespan of the generator, and it's on our end, it's like a $1,000 option. So from a cost standpoint, it's definitely a lot cheaper to keep your generators lightly loaded all the time than have to do, a full rebuild because it gets all gunked up from wet stacking all the time. And that's kind of the good overview of automatic load leveling.
A question came in here, pretty good question, Eric. Does the automatic load step controller fail safe? Meaning, does it remove the load bank completely in the event of a failure? And is there any notification?
In an event of a failure, I'm not sure exactly what's intended. Well, what we're classifying as a failure, but say.
Well, let me try to imagine what he's thinking. So, let's say you lose all control power to that load bank. Will the steps fail open or closed? I mean, they're contactors, right? So they're gonna all open, right?
Yep. As soon as you lose your 120 volt control power, the whole thing it's basically it shuts off.
Yeah, everything.
There's no 120 to power any of the relays, contactors. It totally goes dead. So there's no chance of overloading there. And then also, all of our load banks, stationary, radiator mounted, and these rooftop style ones, whether they're equipped with automatic load leveling or not, most of them, or they all have a load dump feature, which will tie to a normally closed contact. Usually it'll be tied to like your transfer switch. So if the building or the transfer switch changes state, so it goes from, utility to backup, if you're using it just to load test your generator, if it senses that switch and that contact opens, then it dumps all the load as well. So you don't have, so say you got a stationary load bank tied to a generator, you're doing 100% load test, doing your monthly test, quarterly test, yearly test, whatever it may be. But you got that thing running, all out, fully 100% load. And then all of a sudden you actually do use utility power and you need that generator to run your building. As soon as that transfer switch switches over to generator versus utility, it'll drop that load bank off immediately. That way you don't overload your generator and have all kinds of problems, whatever problems may relate to losing power to your building. But it takes the load bank out of the equation there as soon as it sees that contact change states. So that's another major safety feature.
Yeah, another thing I would add, Eric, is that the customer also gets a feedback signal. Like, for example, we have a master relay. We call it K100. It's a safety relay, and it's tied into the air fail circuit, the overtemp safety circuit, and it also gives indication that the blower contactor is energized and the blower is running. So if that relay were to lose power because any of those safeties or the blower operation was compromised, that relay dumps all the load, so everything goes open. Like the person that asked the question said, does everything fail open? It fails open, so it shuts down. But we also have some auxiliary contacts on there for remote indication and alarm, so we could send a signal back to a PLC or a building management system to say, hey, the load bank's taken offline.
Yeah, absolutely. So yeah, you can tie it to a building management system, to a horn, alarm, a light, whatever it may be. We offer an open and a closed contact that change states, so it can be used in many different ways. But there is notification ability to notify whoever's in charge of maintaining the generator operation. So that is a good question, though. There's no chance of overloading your generator, it locking in with all the steps and continually loading if we don't have control power or there's some other failure per se. So, and then
Great question,
I think,
thank you.
Martin, do you have anything else to add? I think I just got a one more slide here for questions and comments. Do you have anything else that we missed or need to dig? You think we need to dig into a little bit more?
No, I think you did very well. I think you covered all the bases. I think it's important for us to listen to the questions now. And
definitely. So if anyone has any questions they want to submit, and take a second, see if anyone has anything they want to submit, and have Michael let us know and answer them if anything comes up, or if not, then we'll get out of your hair.
So I do have a question. So I'm a consulting engineer, say, and I need to specify a generator. And how do I know to specify a radiator mount or a rooftop mount? I mean, is the KW cutoff all the same for all the manufacturers as to when they go to a custom enclosure, or do I have to call all of the generator dealers and ask them?
Yeah, I'll jump in this is Martin Pico. I'll jump in and answer that. It's really hard. I can appreciate what you guys have to do, because you have to write a specification for a specific application. And, when the bids come in, so if you're not specific on whether it should be like a walk-in custom enclosure or if a factory housing is fine, you don't know what they're going to bid. So if we see a specification that is like written for a duct-mounted load bank inside an enclosure, and the genset guy comes to us with a factory housing and says, I want to just put it on top, we'll clarify that and say that we're not providing the standard duct mount, we're putting it on top of the enclosure. If you're specifying, I guess as a rule of thumb, somewhere in that 250 to 300 kW range is when it goes away from a factory housing and now it's into a walk-in enclosure. We can't determine that, but if you're specifying it as a walk-in style enclosure, custom enclosure, then it will be a duct-mounted load bank packaged inside the genset. If you don't specify, then the generator provider will probably pick the factory housing because it's cheaper and it's a nice. There's nothing wrong with it. It's a great enclosure, and then we would provide it as a rooftop at that point.
Answer.
Does that help answer the question?
Yeah. So here's a good one that came in. Is there a rule of thumb that can be used for a dollar cost per kW for the radiator duct-mounted load banks? Just a budget number that a generator dealer could use.
Yeah, a good depends on if it's 208 or 480. So as a rule of thumb, I'm just kind of, let me just run a number here. Let's figure. Now it's about, so if it's 480 volts, you're at about $15 per kilowatt. So 500 kW times 15, that's a little light.
That's about.
You know, if you want $20 per kW is a good number, is a good, fair, safe number. For 208 volt, it's a little bit higher. You know, add 20%.
Okay, great. Another question here. Are the lead times for a radiator mounted duct bank, do they vary greatly over time? Like, say, what's been the lead time at LBD for, say, the past year?
Standard lead time on our end. Oh, you wanted this one, Martin?
Oh, I was going to say it's a little all over the map. It depends on the size, but I mean, on the really larger ones, like a 1,000 kW, those are 8 to 10 weeks after we, have a release for production. But we just did a big job for Caterpillar in New York City, and I think we did those in 4 weeks, so that would be unusual. We don't normally like to build them that quick, or have to build them that quick. But they're normally 8 to 10 weeks on the larger ones. If you're in the 500 kW and below range, we can get those done in 4 to 6 weeks.
Great.
We're always
here's another good.
We're always having to
Here's another good question.
Yeah, go ahead. I'm sorry.
How does a consulting engineer size the load bank properly when specifying? We are held to the NEC to determine loading of the generator, but would typically see a much greater diversity during actual operation.
So it's difficult for us to know. Yeah, go ahead.
Martin, this is Adam. Wouldn't you think? So it depends on if they're using this for, load dumping on the load bank versus just doing a standard generator load bank test, in my opinion, because a lot of times we'll see the requirements they want to do up to 110% load bank test. And so then if it was a stationary load bank, then it would be sized literally to 110% of the full kW output of the generator.
Yeah, I would agree with that. Then you'd have a stationary application. It really depends on the application. If its requirement is to do 100% or 110% or 120%, you really need to have a stationary load bank for that application. And if the requirements are really just a lot of times you can meet the NFPA 110 requirements by just doing a 50% load test for 30 minutes every 30 days. And that's adequate, let's say, for a hospital or a healthcare facility. So then you have the choice of a stationary. If you can, if you can't fit it inside the generator housing, and if you can, then go with the duct mounted solution, because that's more cost effective. That's a great question.
Here's another good question. How difficult is it to remove the load bank controls from the load bank to have them installed remotely? Or do they ship loose for customer preferred mounting location?
So that's kind of it kind of depends on the style of load bank. None of the what we would consider local controls are necessarily removable. So as I mentioned, on stationary units and those rooftop style units, their remote controls are standard, and yes, they are provided as a ship loose box, so it can be mounted anywhere. And then and then there's interconnection required, obviously. But it's not really an integrated part that says, oh, well, if you just disconnect here, you can go mount it wherever and then do your interconnect. It's just provided as a ship loose box. And then on the radiator mounted units, I've actually got a picture here. They would be in this right picture here. That would be what we would consider local controls, which are standard on these units. If one of these, say, where this thing's installed here, this door that they took the picture from wasn't here. They couldn't get to that to operate it. So then they would buy it with remote controls, which would end up totally doing away with that local control panel. There would just be a piece of sheet metal basically filling that square, and then they would be provided in a remote box like you can see here. So that local control panel would go away, and you would get a box similar to this to mount wherever you please to mount it.
Okay. So Eric, I'm assuming I heard what you said, but just let me clarify what I heard. If a person wants a remote control for a radiator duct mounted unit, that is indeed possible. You just have to order it that way. Is that correct?
Correct.
Yeah, if it's specified as a remote, we'll provide it as a remote.
Yep. Yeah, if we ship one with local, you couldn't just say, oh, well, we want them to be a remote now, and then pull the controller out and mount it somewhere. It's something that the wiring's different, the way we have to wire them for like the different panels, et cetera, inside of the unit. They're wired slightly different, so that's not an option on those ones. But they can be ordered either way as long as we know at the time of receiving the order.
Michael, any other questions?
Uh-oh, did we lose him?
He might have had a loose connection.
Oh. My little thing here says he's still here, but that doesn't necessarily mean anything. Well,
maybe he had a power outage and his generator hasn't started yet.
Yeah, it was wet stacking. It didn't fire when they went to fire it up. But well, if we lost him, I hope we're not missing any questions. Since he's the only person that can see the questions. But yeah, it sounds like we might have lost him. So everyone, looks like we got 43 guys in here.
He just sent me a message, and it looks like he did lose connection. Unfortunately, I'm not able to see the questions. So here's what we'll do. There, anybody else is still on, I'll coordinate with Michael if there's questions that did not get answered. We'll be able to see who asked the question, and we'll specifically address the question and get you an answer.
Awesome. So yeah, looks like we got 43 of you guys in here now. So I just want to take a second again. Appreciate all you guys tuning in during your lunch break. I'm sure you guys are all having busy Fridays. Just say thanks for tuning in. If there's any load bank questions you have, you're more than welcome to reach out to our guys at Levine Electronics or us directly. We work pretty close as a team. We'll be more than glad to give you answers, details, anything load bank related. I'm always here, more than glad to help out, as well as the L3 team. So thanks, and I hope you guys all have a great rest of your day and have a great weekend.